This is Related Rates with Brian Martell and Colin O'Connor. Related rates are the rates at which a quantity changes by relating that quantity to other quantities whose rates of change are known. Related rates can be used to solve for the rate at which a ladder is falling, the rate at which something is filling up, and the rate at which an object expands.
First, you take the derivative of the equation. The equation can be found by using a formula given by the shape. Then plug in your given variables and solve for the derivative. Drawing the problem and listing the variables is very useful for these problems. Example 1. A ladder of length 10 feet slides down the side of a wall. Its base is sliding out at 4 feet per second and is currently 8 feet from the base of the wall. How fast is the height decreasing?
Using the Pythagorean theorem, you can solve for b using the given variables.
Once you have solved for b, plug in all your known values into the derivative of the Pythagorean theorem and solve for dB dt. Just remember that the answer is always positive because when you're finding the rate at which the ladder is falling, it cannot be negative. Example 2. Air is being pumped into a spherical balloon at a rate of 5 inches cubed per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 inches.
Since you are given the diameter, you must divide this by 2 to get the radius. Then, take the derivative of the volume of a sphere equation, then plug in your known variables to solve for dr dt.
A water tank in the shape of a right circular cone has a height of 10 feet. The top rim of the tank is a circle with the radius of 4 feet. If water is being pumped into the tank at a rate of 2 cubic feet per minute, what is the rate of change of the water depth in feet per minute when the depth is 5 feet? To begin this equation, we must first find the proportion of radius to height. Then, plug in the value for h that you got for r. Using your new equation for volume, take the derivative and solve for dH dt.